Yeah, it started off in agriculture engineering, food, with an emphasis in food engineering. And I got a lot more interested in drying work. And if you talk about drying, you are looking to reduce the moisture content of food products to some safe level. And I found that very practical in the area of food science. And so looking at drying, how you can make foods safe, what you have to do to achieve that. So if you're designing dryers, for example, then what do you have to do to achieve that goal? So those were very exciting things for me, because a lot of foods are perishable, and just by controlling the how much water you have in there, and as I delved much into this later on, the water activity of those kind of food products, then you can be able to control how long they can store on the shelf. You can be able to know how to handle them if you are going to keep them or to transport such food, or to package them, what you're going to do. So those were very exciting things, and they are of economic importance to both to the food producer and also to the consumers. So I really, coming from an engineering background and getting a lot more interested in the science of water and how it relates to food, those are things that have really excited me over the years, and I think that's how I found my way with more applications in food science. So I have a lot of work going on that relate to monitoring the water content and water activity of the different processed products. One of my students is looking at the berries, how to be able to extract some of the bioactive compounds from berry products. And to be able to do that, we need to be able to monitor the changes in water content, the changes in water activity, and that's why we link that with using the decagon devices, water activity meter, to constantly monitor the state of water in these foods. The other project that I have going on is to extract fish gelatin. We have a lot of byproducts and co-products of food processing, and we want to be able to add value to those products by making other value-added materials. So with the fish gelatin, we are able to form some fish films, edible films, and to be able to do that, we can use those edible films as a form of a barrier to water. So if you're going to do that, you need to know what the water activity is. If you're looking at the permeability of the edible film, you want to know what the water activity is. So that is of particular interest to me in looking at those edible films. So the water activity is related to the glass transition temperature, and as you increase the water activity, the glass transition temperature also changes. And those kind of things affect the stability of the film, they affect the stability of the food. So you want to look at the water mobility as opposed to just getting what the water content is, because it is that water mobility that will affect the shelf life of the product, that will affect how much the films are going to be either flexible, they can be handled. Are you going to produce some products that are brittle? So if they're handled, then how are they going to behave? You want to know those kind of things ahead of time before you put your products on the shelf. So those are some of the things that we have going on right now. So basically, we are looking at some of the food properties, physical properties of food. So with the new products that are coming up, we want to be able to incorporate different berries into a cereal product. We would want to know what the water activity is for that fruit component and what the water activity is for that carbohydrate component. Because if you put all this together in a bag, over time, the characteristics are going to change. And somebody who is manufacturing this product would want to know how it is going to behave 2, 3, 4 days down the road in a temperature environment that is not the same as the manufacturing facility. And also that's why having an accurate and instrument that can give you the results really quickly can help you to prevent some of the losses that you can incur just by not predicting what is going to happen to the water activity of your product when it is shipped to a much warmer environment. So we can do that here in the lab to investigate those kind of things.